I'm going to explain the syntax of the Lambda calculus with a little example. So the idea is that the Lambda calculus is the simplest possible programming language. So we take a simple program from a C-like language, and we are going to simplify the syntax of this program until we arrive at a Lambda calculus program. So let's have a look. So you see this little program here, and I'm going to highlight the things we are erasing, the features we are erasing. So first of all, let's say we don't need types. And then let's say we don't need to write the return, so we just return the last value, so to speak, of the body of the function. And also we don't need parentheses, and actually, as you can see, I'm so used to this that I already left out the parentheses for +1, and also we can erase the semicolon. So let me write this again in a different color. So now we have a different, same program, but a different syntax. So +1n. And I'm going to do another modification. Instead of the curly braces, I introduce some new notation here. I use a dot to separate the parameters from the body of the program. Okay, and then I still have the +1 applied to 0. So that's already quite a bit simpler, quite a bit shorter. So the next thing we're going to do is to say, hey, actually, we don't really need the name here anymore. So let's put everything in 1. And we need a new notation now, or we use a new notation to indicate that we have a function. So we use the lambda to indicate that we have a function. It's a nameless function. The function doesn't have a name. And then we write the n +1. So this is a function which takes an argument n and computes n +1, and we apply this to 0. This is our lambda calculus program. So let me summarize what lambda calculus is. What are the features of a lambda calculus? So we have variables. So n is a variable here. Then we have, it's called abstraction. We can make functions, so this is called abstraction. And we recognize abstraction always has a lambda, and then we have a variable name, and then we have a full stop, and then we have another expression. So let me write the variable as x, and then let me write e for expression. And then we have application. We can apply a function to its argument, to an argument. And application is just written, sometimes we say juxtaposition. So we just put the two lambda programs, lambda expressions next to each other. So there's no symbol for application. As I said, the idea is to be as concise and short as possible. Okay, is that all? Yes, basically, that's all. So maybe you could say, oh, but there's still something more than just variables, abstraction, and application, right? So we still have a plus, and a 1, and a 0. So there are two possible reactions to this. One would be to say, oh, if they're clever, then can we not eliminate, encode +1 and 0? Can we encode +1, 0, and all kind of other stuff we might need for programming? Can we encode this in using only variables and abstraction and application? And the answer will be yes. Another possibility is to add new primitives. So we add +1, 0, and possibly other things as new primitives to the lambda calculus. So one reason why the lambda calculus is a very good starting point is that it's actually easy to add features to it. And this is what we are going to do in the programming assignments in this course.